All right. Hey, everybody. How you doing? This is Serverless Office Hours. I'm Eric Johnson. We are here every Tuesday, this time, this place. We're on Twitch. We're on YouTube. We're in your homes. We're on your computers. We're in your car. We're everywhere. I am excited, super excited. I'm always excited about the show, but for honest, I'm really excited about this one because I've been wanting to learn ML for a long time. And so Newton has promised to teach me everything there is about ML in the next half hour. So I'm pretty excited about that. And he's got that glazed look like I didn't say that. He didn't say that. I know there's a lot to say there, but I want to welcome my guests. These are several of our ML experts, and I'm going to ask you guys to just tell us a little bit about who you are and what you do. And Newton, I'll start with you.
Hi, everyone. I'm Newton Jain. I'm the Senior Product Manager on AWS Lambda, and I'm focused on building features and experiences for our ML customers so that we can make Lambda the most compelling compute service for all their use cases. And super excited to show you some of the use cases and architectural patterns today.
Yeah, seriously, I'm really excited. Anant?
Hey everyone, my name is Anant. I'm a senior product manager on the Amazon EFS team. I've been at Amazon and AWS for close to 5 years, and I'm really excited to be here today as well to talk about the power of Lambda and EFS.
Yeah, same here. And Vadim?
Hi, everyone. My name is Vadim Kaprasenka, and I'm a senior developer advocate. I'm also working as an ANT in EFS team, but I do have pretty kind of solid background in high-performance computing and machine learning and AI, so hopefully I can share my expertise with you guys today.
Awesome. So we already have our first comment of the day. Newton Jain, that is a cool name. We are actually selling that name, so to make some money on this. So it is a cool name. So yeah, if Sahil said to say hello. If tell us where you're coming from. If you're new to this show, tell us where you're watching from, and we're glad to see you. I see John Walsh. He's ever faithful there. Sahil, thank you. So we're going to jump in, and real quick, we want to talk about why ML, right? This idea of, well, not why ML, but why ML on serverless. ML's been around for a little while. I've heard of it. It's been around, for a year or two, right? Or a little longer. But this idea of doing it on serverless is kind of a twist to people. And so I'm going to bring up our slides that we've got here. And Anant, I'm going to let you talk to this a little bit, obviously, and then I'll run the deck for you, and then we're going to. This is not all slides, folks. I promise you. We are going to be demoing actually doing ML, and then I'm going to ask all the questions that you're not gutsy enough to ask. That I am an ML. I can't even spell ML. I mean, that's where we're at. I am really a newbie to ML. I want to learn it. I've been bugging these folks for a while about this, so. Really happy they're here. Hey, San Antonio, Texas, great. All right, so with that, I'm gonna pass over to you, Newton.
Okay, thanks, Eric. So essentially, the reason why we are suggesting ML on Lambda is because we have heard three different things from customers. One is when they deploy their models, they say that they incur high cost, but their instances are still underutilized. So there is a little bit of a contention there. Second is they tell us that they have to have deep knowledge about the infrastructure and they need to provision instances to account for peak and traffic variability. And these are data scientists and ML engineers, and they want to focus on improving the accuracy of their models, not provision infrastructure and set up scaling policies. And third is they want to use more and more of AWS services. And because of those reasons, AWS Lambda is emerging as a compelling compute service for all of your machine learning use cases because it can help you scale automatically. As soon as your traffic spikes, Lambda provisions more functions and scales automatically. It's already integrated with over 200 plus AWS services, so you don't have to write any orchestration code. Essentially, you can just set a write event trigger or an event source, and you're good to go. Third is cost. Again, Lambda has a huge benefit of reducing cost because it's paper inference or paper compute. So you only pay for the compute that you're using on Lambda. So if you're not using these services, or if you don't have any traffic over the evenings or the weekends, you don't have to worry about over provision instances and all that stuff. So cost helps as well. And then simplicity. One of the core tenets around Lambda is this abstraction of operational overhead and improving simplicity for customers. And that's what's driving a lot of the ML customers to Lambda.
All right. So, talk to me. You want to walk through this slide here?
Yes.
Okay.
Go for it. So as you can see, go ahead.
All right. Yeah, you just tell me to move on. So that'll work.
Yes. So yeah, those were the 4 tenets I spoke about. One is cost, because you only pay for inference. So it's really easy. Scalability, as you get spikes in traffic, essentially Lambda instances scale up to meet your needs, and you don't have to worry about scaling policies and setting up instances to account for peak traffic and all that stuff. Again, integrations is one of the best features that we have, because we support so many integrations with other AWS services. Kind of the entire construct around setting up a microservice architecture becomes really easy. And again, all of that ties into simplicity, because Lambdas are just set and forget kind of a setup where you can just deploy something and it just works. And that actually helps you, again, move all the undifferentiated heavy lifting on AWS and focus on improving your business use case. So whether it's model accuracy or whether it's your business logic that can actually make impact for your end customers. So that's what kind of makes Lambda a really cool solution for this.
All right. Jump over here. This is the fun of me running the slides. So, all right. So what are the common learning inference use cases?
Yes. So we are actually seeing a huge surge of a lot of different types of customers deploying different types of ML models on Lambda. We have customers deploying fraud detection models in fintech services. We have customers deploying predictive maintenance models for industrial applications. We have customers doing demand forecasting for, again, finance and other type of applications. We have recommendation models, sentiment analysis for improving support at call centers. We have computer vision models for medical imaging, churn prediction, of course, for all companies who want to retain their customers, and NLP models, just kind of making those chat services. So this is just few of the many plethora of models that Lambda supports and different use cases that we see that are deployed. But again, this list is rapidly growing, and we see a lot of customers extracting a lot of value out of the service.
Nice. And you're going to demonstrate a couple of those shortly.
That's correct.
Really, really excited for. So I like this slide, and this is interesting because, well, I'll let you talk, John. I'm not going to take over, but I've seen this, and I like I like what we're doing here. So I'll let you jump in here in the workflow.
Sure. So this is the standard ML workflow. It starts with the data preparation piece, where where customers or data scientists or data engineers, they collect data, they process it, they normalize it, they wrangle it, they get it ready for training, and then they use it for training models with higher accuracy. Then they tweak and evaluate the models and improve it further. And once they're ready, they actually deploy it for inferencing, so it can actually serve traffic, and then connect it with some monitoring services so they can detect drift and regression inaccuracy. And if that happens, then they restart the entire data prep and training cycle. So this is a continuous loop that keeps on running, that keeps on making models more and more accurate, and keeps on accounting more and more types of requests coming in. So in this case, if you go to the next one, we are seeing that Lambda is emerging as a really great solution for the inference piece. So while you can do other pieces on Lambda as well, our focus today would be primarily on inferencing for multiple reasons. One is that customers have told us that 90% of their actual cost in this entire ML lifecycle comes from the inferencing piece. So we thought this is where we can make big impact.
That's a mind-blowing stat, really, honestly. And I guess, I mean, the inference is where I'm an ML expert now. You've done a great job. But the inference is where, I mean, a lion's share of the work is done, right? I mean, that's where we're getting the advantage of all the work we've done to build these models, is putting it to work. Would that be inference?
Exactly.
Okay.
And once your model is ready, until it's deployed, it's serving customer traffic, it's really not creating any value. So that's the customer-facing piece. That's what actually helps companies make end customer impact, and that's why we wanted to start with that piece first. And also, in addition to that inference piece being the 90% of the overall ML lifecycle cost, we've also heard that most of the models that are actually built, they never make it to production because of various friction points throughout this lifecycle. And you can imagine that's very painful. So a data scientist or an ML engineer working hard and doing all these optimizations, and that model never sees light at the end of the tunnel, not serving customer customer request or not solving some customer problem, is a futile effort. So that's why we wanted to streamline the last piece first to get your models into production as quickly as possible, and then work our way into other pieces of the life cycle too. So that's it's not the end all be all. We want to expand, but starting with inference, that's what was the right solution for us.
And I love Dan MBA just said making the model equals cost, inference equals benefit. I like that. That's really cool. All right. So let me jump in ahead here. So
yes, so there are 3 patterns that are very common on Lambda for doing ML inferencing, and I will be demoing all 3 of them.
okay.
But these are just kind of going over how the architecture is set up. So one is container hosted. So as you know, from reInvent last year, we started supporting container images, and now what customers are doing is they are actually packaging their models, their dependencies, and their inference code all in a Docker container and deploying that on Lambda and connecting it with an event source, whether it can be API gateway, S3, SQS, Kinesis, you name it. And essentially that model is now serving requests. And all of it is all in one container. It's very simplified. So that is one very common, simple pattern that we are seeing to get people up and running on Lambda. Now, as your use cases become more complex, this is the second pattern where you might want to do model management, where models are changing very frequently. So it doesn't make sense to just update your containers every time there's a tweak or a change in the model. So in this case, you can actually decouple the inference code from the model, and you can put all the models in in an external storage. And we have 2 options for external storage. This is one of them, which is S3. And you just connect S3 to your Lambda function. So your Lambda function stays intact, and whenever your model gets updated, you just update it in the S, and basically it's used in production. So that's the second pattern.
Okay. So real quick, I want to touch on some of this. So the value of this is I don't need to redeploy the inference Lambda function. I just redeploy the models or update the models in S3. However, and this is why we're going to the next one, and we're going to cut Vadim loose here and let him just go for it. But the other thing is what happens when these get just really big, when these get really, when we've got to go and we're grabbing these objects of S3, and so there's a cutoff line, right? Where we say, this probably isn't the best or most efficient way to do it. It updates fast because we can update the models, but we may not be able to pull them in as fast as we need them. Is that a fair statement?
Yes. So there are ways to optimize it further in terms of when your model volume increases, when your model size increases, when you have very stringent latency requirements. And that's why, in addition to S3, we also support EFS, which is the next slide. Perfect. And this is a very, very cool and a very relevant use case that we are seeing, where customers who are doing multi-model inferencing, which is kind of a new pattern now, where instead of training a one monolithic TensorFlow or PyTorch model, they deploy a lot of these smaller models that are custom built for individual users. So you can imagine these model volumes can be in hundreds or thousands or even tens of thousands. And each model is uniquely serving one individual customer. So when you have so many models and you have the same inference function, and based on the request coming in, you need to pull in the right model and use that to produce an inference and send it back. This architectural pattern is very handy. So EFS is an external file storage that you just mount on your Lambda. You put all your models there, and you can set your provision throughput. You can set your IOPS. You can set all of your download speeds, and then from there you can actually start serving requests that are coming in. And then Anant and Vadim would be able to talk more about the EFS side.
All right, awesome. Okay, all right. So we're going to be talking more with Vadim and Anant when we get into the demo as well. So, all righty. Hey, Alan London is new here. Say hello. How are you? Hello. And I probably said that wrong. Ale London, maybe. I just want to apologize to Vadim and Anant, because I know I've said their names wrong repeatedly, and for you joining us. I'm just not good at names. So I have 5 kids. Their names are 1, 2, 3, 4, 5. We've kept it nice and simple. All right, so let's jump on here. So, let We got some. So we've got a couple companies that are doing this, and I'll just buzz through real quick here. ML is not something. Oh, it's kind of nice. It's something being used. Asherion is a company that's using it to perform real time. And you know, I'm going to kind of buzz through these, Newton, if that's okay.
Yep.
The other one is Willy Weather. They use real-time data from 70 radars across Australia to predict rain and small-scale storms. Maybe we're getting accurate weather people for once, you know, with this kind of information. So, and Amplify. And this is not the Amplify like the Amplify framework that we use, but they variable traffic machine learning workloads on AWS Lambda. So they're doing a lot of the developing artificial intelligence solutions. So they actually help folks do this on Lambda. Is that correct?
That is correct.
All right.
Yes.
All right. Very cool. All righty. So we're going to jump out of there, and we're going to. I'm going to turn it over to you. We've got your demo up here, and let's see some ML. This is the part I'm excited about, is to actually see it in action.
Yes. So I have 3 demos set up for you today. 3 very different demos and very exciting ones. And we also want to showcase one of the recent launches around SAM/ML templates that we just did. The blog is published and everyone can check it out.
Yes.
So
I'll be posting a link to that. So
perfect. Thanks, Eric. So starting off with the SAM/ML template. So we recently published 4 templates in SAM CLI. We saw a lot of the customers, they actually congregate around SAM as their to basically simplify their build package and deployment pipeline on Lambda. And we realized that we can actually simplify their ML journey as well, make the onboarding experience very straightforward by launching these targeted ML templates for TensorFlow, PyTorch, XGBoost, and scikit-learn. So that's exactly what we did. We launched 4 specific templates, and the goal is to actually get you to have a very basic model set up locally that you can test and then deploy it in Lambda within the first 10 minutes of you interacting with it. So quite an ambitious claim, but let's see how this works. So if you actually go into your SAM CLI, you can actually use the SAM init process, and you can actually select quick start templates. Then you can select images as the application type. And right now, the templates are only supported for Python 3.8. So you'll have to select that as the base image. And then you can give it a name. I'll call it demo serverless. And here you see 4 different options. So this is a list of templates that you would not have seen before. So we recently launched them. And if you want to start with a Hello World application, you can just do that. It's a basic Python Hello World app. But the other 4 templates over here, they're very purpose-built ML templates. So I'm going to start with the scikit-learn template, and I'll show you what's in it as well. So let's start with the demo serverless. So here, we give you the full setup to get your basic model up and running locally in SAM, and then to deploy it on Lambda. So essentially, we give you a CloudFormation template. And let me open this over here. So this is the blueprint of the entire application. We set up the inference function. We set up an API gateway endpoint with a classify digit endpoint over here. And we give it all the appropriate permissions. And inside the application, we ship a very basic digit classifier model. You can think of it as the hello world of ML. So here we are using the MNIST dataset. We train the model to classify these handwritten digits. And as a matter of fact, we even ship the entire training notebook with the template. So if you want to tweak it, update it accordingly, it's in Jupyter, so that's why it's not showing up over here with the right context. But the training notebook is available with the template, so you can tweak the model if you need to. But the model, the pre-trained model, is shipped with the entire template as well. And the Docker file and the handler code is very straightforward. Essentially, it looks for incoming request and essentially processes it through the pre-trained model and then produces inference result. And the Docker file pretty much packages everything, creates an image for you, and then you can actually deploy that on Lambda. So let's actually try that out. So now if I go and do SAM build, as you saw, like within 5 seconds, you have build step done and your application is ready to be tested. So what I'm going to do is I am going to test it locally first. Oops. There we go. So essentially what it's doing over here is, so as you can see, it can give you a prediction label over here. And how it's doing that is in the events, we have an event.json that actually sends a mock payload to this handler whenever I invoke the function. And in the mock payload, I have encoded a image of a digit in base64 format. And essentially, just to very quickly test that my model is working, you can think of it as doing trust-driven development to validate nothing's broken over here. So you can quickly test the accuracy of the model. Also, if you want to take it a step further, I also have it set up over here. You can actually set up the local endpoint. And let me just show that how you do that. So you do SAM local start API, and it will set up a local endpoint on port 3000. And it can start serving traffic from localhost, from Postman or whatever tool that you use to make post requests. So here I have an endpoint called classified digit. So that's the same endpoint we just saw in the CloudFormation template. And now I have this set up over here. I have the localhost 3000 classified digit endpoint. I have image of Amnes dataset. I have a few images actually, so let's just use 2. And now I can make an inference on it, and it's essentially making the inference against that model that's running locally, that's emulating the Lambda-like environment on my machine locally, and sending the request. The model invokes, the Lambda invokes and actually produces the inference, and then gives me the response back here. And I can do this with multiple images and just validate the accuracy of my model before I actually deploy it. There we go. So
now I'm going to jump in real quick and explain. We have latency going on. That latency is not SAM or the SAM template stuff. We've had some issues with the machine. very, very honestly, I know Newton. I'm calling you out, Newton. But yeah, so we've had some issues there. But one thing I would say, hey Newton, pop back over to your SAM.
Yes,
if you would please. And no, I'm sorry, no, the actual local version.
Mm-hmm.
And so what happened here is it actually takes and loads up a local version of the image. It mocks this API gateway that wraps that. Can you stop that?
Yes.
Okay. And now do it again. Don't start it. Just do the same local start API. No, not the API from the command line. There you go.
Mm-hmm.
Now add. Oh, nope. Stop it for a second. I'm going to have you add a flag. I want to show I'm going to teach some folks a little SAM real quick. Add a flag, dash. And I didn't prepare you for this, so I've blindsided you here. So everybody knows and then type warm dash containers space, and then all caps say eager, EAGER. Now what this does is this is going to start SAM local. Yeah, go ahead and hit into there. And it will do the same thing, but it'll only load the container the first time. And so he can hit it over and over and over. Maybe I warm container. Tried no S on the end. So it's gonna be very embarrassed. Yeah, warm container. There you go. It's gonna be very embarrassed if I give you the wrong flag. Okay, so I'll look that up. We might have a different version of SAM, but just so you don't have to wrestle with it right now. I'll grab that and get the documentation to it. But if you're running this and you have the newer version of SAM, if you add, and I can't believe I don't have it in front of me, but if you add this -- warm - containers, and then you say eager, then what it'll do is it'll keep that loaded and not have to redo it each time. Now I am going to jump back, and Anant and Vadim, you guys have been sitting there patiently. I'm going to ask you a question. One of y'all, we had a question come up, said, how is this different to SageMaker? Why would I be using Lambda instead of SageMaker? Do one of y'all want to field this one?
I think I want to jump on this one,
Okay.
if you don't mind, Anand. So in my mind, SageMaker, it was kind of designed for all the steps. Remember, our workflow for machine learning includes training, data cleaning, preparation. So SageMaker is kind of helping you to orchestrate all of that, keep track of your models, and kind of do all of that. But you can imagine, like, that's a lot of functionality, and it is SageMaker is huge. So what Newton is showing here is basically a lightweighted way to serve the inference with Lambda. So if you don't need all this kind of heavy machinery of training your model, if your model is already trained, then with Lambda, you're just getting those lightweight implementation of the inference serving.
All right, thank you. So it's back to that idea of we can do a lot of work before we get to the inference, but the inference can be the hardest part. It's that deploying it to. Sorry, I'm not trying to change your answer. I'm just adding on to a little bit. It's that getting it out to the users, what you were saying, how many percentage of them just die there? So we can use the SageMaker, but then, oh, my video's gone weird. Okay. It's technical issues.
You're a
today,
ghost now.
but this really isn't. This is probably an improvement in a lot of ways. But and I'll work to fix it here. There we go. Yeah, so it's that SageMaker is still valid in the process, but you know, Lambda allows you to get that out to your users. So, all right, thanks for answering that. We got some Lambda questions coming up that I'll try to answer in a little bit. But yes, this is a serverless office hour, so we'll answer any of them. All right, Newton, I think you just have an older version of SAM. That's the reason I did post the link to that warm containers. If you're doing SAM local and you're wanting to do this, I heavily encourage you to use warm containers. It helps out a ton, makes it fast, makes it much more responsive after the first call. So
yes,
Newton, I'm going to turn it over to you for the second video. I'm going to see if I can fix my video.
Yes. So essentially now when you have tested the templates locally and you're happy, you can actually go through the SAM guided deployment experience and deploy the entire application on AWS. So when you do that, essentially it will ask you for the name, the ECR repository link, a whole bunch of other details. And once you fill that out over here, as you can see, I'm not going to go through the guided deployment. It's going to take 30 to 40 seconds, but essentially I can specify all the details over here and just default to the configurations that are predefined. And essentially it will start the deployment process for this image on Lambda. And once it's deployed, you will actually get an endpoint on API gateway that you can actually start sending your inference requests to. So I've already done that beforehand because I wanted to save time for our audience. So I have this endpoint already deployed, exactly the same application out of the box template. I haven't changed anything here. And now I can actually start sending inference requests to it. And now you can actually see the latency. So you can get triple digit latency over here. So I'm going to try with some other images over here, basically just to get the accuracy testing. And yep, as you can see, all of it is now functional. So I went from actually having nothing set up to have a digit classifier model deployed with SAM template, tested locally, built, packaged, deployed on AWS Lambda with an API gateway endpoint, ready to serve traffic from anywhere in the world. So all with the power of these scaffolding templates that we are shipping today. So we hope you all use it and it streamlines your onboarding journey and it lets you deploy something very simple on Lambda to just get you that early win. And then you can actually replace the model and the inference code with your use case specific models and make it more sophisticated and kind of gives you that stepping stone to building something more complex and impactful on Lambda.
Awesome. Hey, so we had a follow up on this. So basically, and Anant or Vadim, if you guys want to do it. So basically, I'd be better using SageMaker for fully. How y'all doing? They pay me to speak here at Amazon. So basically, I'd be better using SageMaker for a fully fledged solution versus Lambda for local development inference serving.
So I wouldn't say local development. You can definitely do development locally, and then deploy the entire model with the inference code with all of your dependencies in Lambda. We're using any of the three architectural patterns that we showcase, which is container hosted, S3 hosted, or EFS hosted, and actually use that to serve your production traffic. And it will automatically scale up and down, scale to 0 when there's no traffic, and basically give you the latencies that you need. SageMaker is really great because it sets up the end-to-end pipeline. So if you want to do training and you need GPUs for that, or if you want to do model tuning, or if you want to do something more complex, that's where you can use these managed services that SageMaker provides. Many times I do complex model training on SageMaker too. And when I need to deploy them, I then move over to Lambda and then deploy them on Lambda. You can also deploy the models on SageMaker using the MME, multi-model endpoints. It is instance-based, so it comes down to your requirements. If you want a more serverless-like experience, you can deploy it on Lambda. If you want more instance-based experience, you can deploy it on SageMaker.
So I'm going to ask, I'm sorry, did I talk over you?
No, go ahead.
Okay, so I'm going to ask this question. So if I'm understanding you right, and this is a legit question, I'm not trying to teachable moment here. My question. So SageMaker could run all of this. Back to our diagram, you said so SageMaker is where we're kind of doing all this, and then we can run a Lambda function for inference. So it's kind of this. It's kind of a could you use both, and would they work nicely together?
I think the answer to this question, yes. And maybe it will be integrated fully at some point, right?
Okay.
But right now, SageMaker allows you to go through all of those steps.
Yeah.
But we are specifically discussing inference with Lambda at this point.
Right. So and so you could you generate the model with SageMaker?
Yeah.
And then you use
and then just
model.
grab it. Exactly.
Yeah, exactly. Yeah, there you go. What? Eric,
yeah,
2 points for that. All right, there you go. 2 points. What? All right. I'm going to bring in your screen again, Newton. And Ananth, man, if you want to throw anything in, I think I talked over you earlier, but just interrupt me. Everybody else does. So, all righty. All right, the detailed explanation. So you bet. Okay, so back to the next demo.
Yes, so now demo number 2 is now deploying an NLP application on Lambda. So we just deployed a digit classifier using the SAM templates. And just taking it a step further, essentially what this is going to show you is the S3 hosted architecture. So I use the same SAM templates, and now I'm actually increasing sophistication and just adding my business specific code in it. So I've updated the inference code to actually now do inferencing on text corpus coming in and do machine reading comprehension. So what this will do is I can give it a corpus of big text. I can give it a question, and it can understand the context of the question, and it can actually generate the response or answer from the corpus that I've given it. And the way it's doing that is it's using a distilled BERT model from Hugging Face, and I'm actually downloading
hold on.
too many things.
Okay. What? Whoa. Okay. There's a couple of words I don't understand. Okay. Number one, are you saying, is it corpus? Is that what you're saying?
That's right. A text corpus or a paragraph.
Okay, there we go. Okay, I didn't know. Okay, all right. So that's Eric's. He's not smart. But this, okay, here's a huggy kissy face. What are we talking about here? So these are terms that I've never heard about. So what is a huggy kissy face? Other than an emoji and yeah.
You can think of Hugging Face as maybe a centralized repository where all the NLP models and NLP applications are kind of available. They have their own set of optimizations on specific NLP-based models. They use transformers to just improve accuracy. It's a really cool project. I would recommend people to check it out. If you're doing NLP, you know Hugging Face. Basically, it's like it's like a model.
Project or brand.
Yes.
Okay, all righty, man. I think we need a cooler name than serverless. I'm gonna high-fiving or I don't know something. We'll think of something. So go ahead. All right, now I know what Hugging Face is because you gotta admit that's a little random. It's like what?
I actually like hugging kissing faces. I think from now on I'm gonna be calling hugging kissing faces for sure.
I'm gonna submit a PR to change that. I'm sure they'll accept it. So,
yes. So BERT is an NLP model type. Essentially, again, there are different types of models. There's GPT. There's BERT. They're all very specific types in the ML world. if you're doing NLP, again, these are some of the pre-trained models you might use, or you might make your own. So BERT apparently is very accurate, and it's used in a lot of different types of applications, from doing customer sentiment analysis to keyword extraction, to doing keyword tagging, auto generation of text, and all that stuff. So what we are using BERT here for is doing some machine reading comprehension. Essentially, when you're building an application like that, you have a model. So here I have a PyTorch model, BERT model, and then I have some tokens that go with it. So there's a few configs and some tokens, and I can update any of these files. So my data science team, as you can imagine, they're working behind the scenes, and they're constantly improving the model, the tokens, the configs, all these configurations, just so that they can produce the highest accuracy for the end customers. So over here, instead of now packaging everything in a Lambda container, what I can do is I can use that external storage paradigm that we talked about, and I can put all of these models and configurations in S3 and load them during init time. So when the invoke comes in and the Lambda function is spinning up, I can just load that once, and then I can start serving requests within my handler. So that's exactly what I'm doing here in S3. I'm just downloading all the necessary configurations that I need for this application to serve my inferencing request. And then in the handler, I'm just taking the body. I'm actually taking the question that the user asked and the paragraph that they provide me, and then essentially just passing it through the model and generating a response from them. And I'll just give you a demo of that as well. And here, if I look at the requirements, the TXT, basically I'm just downloading the transformers as my dependency. And it's quite straightforward to set up. And let me now actually do a demo on that. So what this looks like. So I've set this up on AWS as well. I've gone through the SAM guided deployment and all that stuff just to save time. And essentially here I have that endpoint, and I have that question that I was talking about, where I have to extract the context from. So here I'm asking, when was the car invented? And I'm giving it a paragraph. And inside this paragraph is the answer, but I don't know where the answer is. Now the ML model is going to parse through this paragraph, extract the context, and actually match what the answer would be for the question that I've asked. And hopefully all in real time pretty quickly.
And that's a corpus, by the way. I'm just saying.
That's right. So this is the corpus right here.
Just throwing that out there. So, all right. Okay, so we're waiting on that. I'm going to grab one of the questions we have here, if that's okay. All right.
There we go. We started getting a response back.
There we go.
So first time you might see a cold start, but then again, subsequent requests, we are answering that in triple-digit millisecond. So now the answer of when was car invented is 1886, and the answer is hidden right here. So the year 1886 is regarded as the birth year of the modern car, when blah blah blah. So this was nicely, sneakily hidden there, but now the model can actually extract that and give the response back.
Can you play with it? If you ask not when, but where was the car invented? Just kind of curious. I'm always interested in picking the models to see how they work.
Let's do it. Let's break Newton stuff.
I know. There you go.
Oh,
wow.
Well, it misspelled it, but
that's
fair enough.
There you go. Cool. Let's try another one. So here is a bigger one. So how many kilometers of rainforest is covered in the basin? And there's the answer somewhere in the paragraph. And let me allow the application to do the heavy lifting. So here the answer is right there, 550,000 square kilometers.
Yeah, I am learning faster than the ML model. I'm fast. I can count to 2. So, all right. Did you get the answer? Nice.
Yes.
All
so
right.
550.
All right. Before we jump to demo 3, are you doing another example of this one?
No, these were the 2 examples that I had.
All right. Before we jump to demo 3, or while you're kind of setting it up, I want to answer a question that's unrelated to this, but this is Serverless office hours, so we answer all the questions we can. And this was, by the way, I was taught how to say it. It's Ale London. There we go. Welcome, Ale London. So the question is, I'm doing some Puppeteer file upload on Lambda. The file shows is uploading in the browser, but hangs on 0 upload forever. Are there network issues, configurations I need to be aware of to successfully upload a Puppeteer browser on Lambda? So I'm going to be real honest. I'm not familiar with Puppeteer. I've used Puppet. I have no idea if those are the same thing. I'm assuming Puppeteer is more of a like a headless browser type idea. If you're wanting to upload files, I'm going to take that part of it first. Okay. So if you're wanting to upload files, yeah, there's not necessarily constrictions in the network or the broadband, but it's more about API Gateway is going to have a timeout of 29 seconds. And there's some limitations to the upload size that you can do. If it's possible, and I don't know exactly with this particular scenario, and I'll have to do a little research to get some more, but I'm gonna say this anyway so you hear it. If it's possible, if we need to upload large files for a Lambda function to make use of, or for it to do some action on, it's better to upload it directly to S3. You upload it directly to S3, then you can get an asynchronous event that will trigger a Lambda function that you can pass that file to. So what happens is you're no longer going through API Gateway on a synchronous call where you're bottlenecked, because you're bottlenecked kind of by synchronicity, right? You're now moving to asynchronicity or asynchronous calls where I drop that in a bucket. And when you talk directly to S3, you have a lot more pipe, or you have a lot more size. You can multi-uploads to, I think it's 5 gig is the limit on S3 uploads. So you have a lot more room to upload stuff, and then you can asynchronously trigger that Lambda function and do some work if you need to. So hopefully that helps answer that question. Bottom line is, and there are some rare use cases where it makes sense to directly upload into a Lambda function. I've talked with several folks where they're doing some very specific changing things that they need to directly upload, but 99% of the time it's better to directly upload directly to S3 and then asynchronously invoke that. So hopefully that helps. And here we go. So Newton, we had a question for you. Newton, both demos were using container options, right? As opposed to S3.
Correct.
Oh, right. Okay. Okay. There we go. All right. All right. I'm going to turn it back over to you, Newton. Hopefully that answers your question. If that didn't answer your question, please hit me. My Twitter is right here, EDJ Geek, and I will get you a better answer if that doesn't help you out. Or feel free to throw it in here again. So, looks like it helps. So great. All righty. Back to you,
awesome.
Newton. Cool.
So
Newton.
now taking it a step further, and now getting into the multi-model inferencing scenario. So this is where I spoke about there are multiple models that are serving inference requests from different customers based on the request parameters or request metadata that's coming in. So let's say I am in Canada. There might be a different model that's serving the requests coming in from Canadian users. There might be requests that Anant makes, and that there's a different model that serves the US users. There's a model from Europe, and you can get the idea. So they can have multiple models that are geographically targeting different customers, or they are maybe targeting different types of use cases. So for example, if I send a request for getting an insurance quote, maybe based on my background and my age and my information, I get a unique code versus when Anant or Vadim sends that. So there could be individual model customized to each user that is actually generating unique predictions and driving higher accuracy. So in this case, we are doing a demo for multi-model inferencing, where I'm actually going to be doing OCR on an image, on a bunch of image actually. And the model will extract the text from the images. And this would be language specific. So I'll send an image in English, and I'll send an image in Mandarin, and then I'll send an image in maybe Russian or Hindi, and it will be able to extract the text out of that. And the reason why we are doing this multi-model inferencing is we want to showcase the power of EFS now. So now I have actually mounted an EFS file system onto my Lambda function, and all my models are in that file system. So if my ML team is actually working on improving the accuracy of those models, they can just update that EFS file system. It's automatically mounted here on my Lambda function, and it just pulls in the appropriate model based on the request that's coming in. So I evaluate.
Hey, Newton, can you show the template where that EFS? I'm sorry, I like to break your train thought as much as I can. Can you show the template where it's showing that mount of the EFS?
Yes, let me just sign in to AWS, and
Oh no,
I have to open my console.
Does the template down here, the same template, do it?
So it's already mounted onto my console, in my AWS console. So I'll have to show it on the console.
Okay, then don't worry about it. Yeah, we have examples of how to do that in SAM to mount those as well. So yeah, we'll make sure. Yeah, so all right, sorry, don't worry about it. I just wanted to see if we could pull that up.
Yeah, I just kept the templates very lean so that I could quickly do the demos. But essentially, and that's the power actually. So I don't have to worry about my models. I actually can just write my inference code here, and all the models can be in EFS. And I just mount that EFS and pull in the model during the invoke time, and it can be used to serve the inference request. So
awesome.
When I want to test it locally, I can actually have a directory locally. So these are the list of all the language specific models that I have. I just kept it here to showcase what's in EFS, but I'm not deploying the container with these models. I'm just deploying my inference code and connecting my EFS, and that contains all the models for me. And if I want to test it locally, I can, of course, add my models and do the local invoke and all that stuff. But when I'm deploying it in prod, I can comment that out or delete it, delete the model directory. My Lambda function becomes leaner, so it helps you with good cold starts as well. And then EFS takes care of doing all the heavy lifting of managing multiple models for me. So let me just give you a sense of what this application is doing. So let's start with request. So this is a Chinese sign. Let me show you what this image is. So here's a sign in Chinese, and it has some Chinese and some English, and I want to extract the text from this image. And now when I send this image to Lambda, essentially what it's doing is pulling in two models from EFS. It's pulling in a Chinese model and it's pulling in an English recognition model, and it's producing the result for me. So the first one, of course, takes a little while. It's cold start, but now if I do subsequent, basically it's doing it 1.5 seconds. So it's giving me the text in Chinese and also in English. Let's actually take it a step further. I'm going to do Russian now. So I'm going to send it an image in Russian, which is the language. So here, the way it's determining what model to use is based on the language code that I'm passing. So here's the language code for Russian. And let me also show you what image that is. So it's a bunch of just Russian characters here. And then once it's done, it kind of gives me the response back. Taking
what does that say? Vadim, do you know what it says?
Yeah, it's basically Russian alphabet.
Nice. Really that's what I was going to say. Awesome.
Awesome. Vadim can give us a more complex picture next time, maybe. Then let's look at, so this is now English. So essentially what I'm doing is I'm actually taking one of the testimonials that customer wrote on Lambda. And let me just show you the image as well. And just an image over here. And now I actually want to extract text. And this now can be coupled with the NLP that I showed you with BERT, or it can be coupled with other ML models to actually do tagging, sentiment analysis, whole bunch of other things. But here, essentially from that image, it extracts the text for me. And this is just using the English model. And just to kind of, for the sake of comprehensiveness, let's do Hindi as well. Why not? So here, essentially there's a poem in Hindi, and I'm just sending the image, and now it's going to extract the text for me. And as I was making those requests, every single time Lambda was actually pulling in the appropriate language specific model from EFS and serving it, and all of it in real time. So this is where using this combination of services with Lambda really becomes a very powerful tool set for ML engineers to do a lot of diversity of things and a lot of different, and support a lot of different types of use cases.
This is super cool. So let's talk about EFS for a second. So we've changed. So first we did, where everything was contained in a container, and you have up to 10 gig that you could do that, right? But then we say, okay, well, we want to be more, really the advantage of, and correct me if I'm wrong, the advantage of S3 is not so much bigger objects. That's where we would kind of go to EFS. But the advantage of S3 is the flexibility to change a lot, right? But when we get into these bigger objects and need this flexibility to change a lot, would that be the EFS answer? And either Anantha or Vadim, is that a fair statement?
Yeah. So
Okay.
so if you think about it, a quick summary would be a lot of EFS's properties are shared with S3, right? So when you talk about, let's say the regional services, they're both shared, and you can use it. The two reasons that really inform whether EFS or S3 is the right choice for Lambda are one, if you're modernizing an existing application that deals with files, right? So in this case, you have a lot of files, a lot of reads, a lot of writes, or a lot of opening and closing, and so on. So in that case, dealing with a native file system is just better because it's fully optimized for doing stuff like that, right?
Sure.
When you think about the second reason, let's say access patterns with S3, you typically have to download or import import an ML model every time, and you also have to kind of build in logic to see whether the S3 object has not changed, and so on. With EFS, all of this is kind of natively available. It also provides caching under the hood, kind of what Newton talked about in terms of the first time you might have some sort of warm start, but after that it's essentially instantaneous the moment you pick up files from EFS, right? And so and then the last thing is a little bit from a cost perspective. EFS, you don't pay for data access typically if you're running read heavy workloads, so you only pay for your underlying storage. So in case if you have like ML inference models where you're reading continuously a lot of data, it might sometimes be a little cost effective there as well. So there are a few reasons why S3 where EFS might be an optimal choice for ML inference.
Okay. So, and one other thing I would throw on there is the temp directory, which you're working with when you work with S3. You're limited, right? You have 512 meg. That's the biggest. And so if your models are bigger than that, they're not. They're not coming.
Yeah, but EFS is elastic, and
it's almost
because
infinite.
you need it.
Yep.
Yeah. So, all right. So, talk to me about predictable traffic patterns or the lack of predictable traffic patterns. I really hope Chris is watching this because I can't talk. It's like, we're going to fire this guy. But talk to me about how traffic patterns work and affect and work with EFS.
Sure. Okay, maybe I can take it, and maybe Vadim, please feel free to add. So from an EFS perspective, we do provide two throughput options or throughput modes when you with EFS. One of them being bursting throughput, and the second is provision throughput. And essentially, the throughput of your file system depends on how much data you're storing in it. If you're in bursting throughput mode, alternatively, you could have a throughput mode where you want to switch, where let's say you're operating on a small amount of data, and you want a higher amount of throughput on that. And so before we introduced this notion of provision throughput, what a lot of customers ended up doing was adding and trying to increase the size of their file system. But now with provision throughput, you can say, hey, my model size isn't that big, but I really want to have a lot of throughput on it, and so you can go ahead and set up provision throughput, right? So we really provide the flexibility for you to choose depending on the size of your model, the amount of throughput that you want from your EFS file system.
This makes me smile because I'm pretty sure that's when cat videos came around. We need space. We need to fill up. Look, I have TIFFs of cats in there, so there's your space. So okay, so what's the max read put? What are we looking at when we talk EFS? What is my max on that, and what happens if I need more?
Vadim, you want to take that? I can go for it.
On top of my head, I remember that we tripled read throughput, and specifically we done it for Lambda. So for majority of the regions, previously the maximum provision throughput, you could have set it up to 1 gigabyte per second. But with tripled reading throughput, you basically can get as much as like 3 gigs per second reading files, which is usually quite enough.
I just pasted the link to that as well in the chat, where we recently introduced a 3x read throughput at no additional charge.
Okay, so what happens if I go, boom, I'm maxing, I need more? What do I do?
You should take it.
Anant, do you know?
Oh, sorry. That is for me. Okay.
Yeah, that's right. Yeah. Vadim,
yes.
Vadim absolutely.
I'm just joking around. Sorry.
Yeah. So basically, typically what we say is if you're using your bursting throughput, you can continuously monitor your throughput through CloudWatch, right? So that way you know when you're kind of hitting your utilization, whether 60, 70, 80%, and that way you can increase the size of your file system, for example, or create another file system, or switch to provision throughput, for example, right? So the best practices I would say are monitor using CloudWatch to make sure where your throughput limits. The second is if you feel that you're really going to be heavily hitting your EFS file system, think about using provision throughput, for example.
All right, so that's the answer.
Yep.
Okay. Gotcha. All right, so we had a question out there. It says, would these SAM templates you presented be compatible with, possible to integrate in an AWS Chalice application? What do you think? I have an answer, but you want to go for it?
You go for it, Darren.
Okay. Yeah, so these are SAM templates, right? So the magic of these are they're bringing in the right libraries, and then it's example code, right? It's example code of, here's how I make that scikit call. Here's how I grab that inference. I'm using ML words. How cool is this? So here's how I infer that. But if you wanted to do it, say, you know what? Excuse me. I want to move this over to Chalice. I want to use Flask. Then yeah, I mean, you could take I know. I'm more familiar with Flask than I am Chalice, so I'm gonna say Flask. I know that, and you're like, but that's not the question. But this is the answer. So Ali Spittle and I did a demo on doing Flask inside of SAM or inside of Serverless. And it's just code at this point, right? So you can run this Chalice inside of a Lambda function. You can run it in there. I think Chalice is a little more of a framework than just SAM, so you might have to do some modifications. But at the end of the day, what these SAM templates are doing is gathering the right libraries and example code of how to make ML inferences. And so, yeah, you could probably migrate that over at some point. Hopefully that helped answer the question. We have their question here: how does end of day on Fridays affect throughput in AWS? I always see I'm not sure we have data to back that. It may be anything you're doing that's human interaction. I know I slow down on Fridays, but yeah, I don't have any data to answer that question. So Kendera said my answer did help them. So somebody write that down. And with that, we're at about 3 minutes out. So if you have a last minute question you want to throw in there, if not, we just got face head. Yeah, we got icons going on, so that's okay. Vadim, Anant, Newton, I just really want to say thank you for coming. This is fascinating to me. This really is something I want to get into. I learned a ton in kind of working up to this, and then and in going through this. And I don't know if you want to say anything just before you go out. Any plugs you want to throw in?
No. Thanks for having us.
If you have any questions, again, reach out to any of us. We're gladly going to continue this conversation even offline.
Absolutely. And our Twitter handles for Vadim and I are there, and we know how to get a hold of these other gentlemen. We did have the question, where can we get the example code? That's the beauty. SAM, it's already part of SAM. So if you want to download that and move it somewhere else, that's fine. But SAM init, follow the instructions. We posted the blog earlier, and I will post it again real quick here. And it shows you exactly how to get your hands on this, on the templates and work it. So there you go. All right, with that, I'm going to sign us off. I really, really appreciate y'all watching. I appreciate y'all presenting. Have a good day.
Thank you, guys.
Thanks, everyone.